For lesson 5, we are getting into a brand new topic. It's one that you maybe have not heard before. Maybe you have, but it's working with matrices. Matrices are nothing more than a rectangular array of numbers. It's a system, it's a structure that allows us to just view those numbers very quickly and understand what they represent. So, a matrix. With a matrix, that rectangular array, a length by a width, we have these things called rows and columns. So when we define the dimensions of a matrix, we're going to go by m rows and n number of columns. Okay, so m by n. And let's go ahead and define the next one right away. Each value in the matrix, which is also called an entry, it can also be defined as an element. So again, matrix is nothing more than a rectangular array of numbers. Here's an example of a matrix M. Okay, we have 82, 54, and so on. If we go back to defining the dimensions of this matrix, we start by the number of rows that we have. Rows are horizontal. So how many horizontal lines do we have? Well, we have 3 of them. How many vertical sets of numbers do we have? Well, we have 4. Therefore, we would define matrix M as being a 3 by 4 matrix. If we take a look at F, it's the exact same thing. This would also be a 3 by 4. The numbers that make up the matrix are the elements or the entries. So 71 would be considered to be an element of matrix M. First thing we can do with matrices is we can simply add them together. And if I'm guessing, if you had to predict your own method to how you add these, you would simply say, well, we need to take 82 plus 91, and you would be correct. We use the idea or the term corresponding elements. 82 corresponds to 91, which means it shares the same location. So basically, you add up the same locations of those values. 2 and 1 is 3. 8 and 9 will get a 17. It's Ashlyn and Sydney will do row or column 1. Paige and Hunter, go ahead and do row 2 for me. Abby and Haley do column 3. The rest of you can add up column 4, and then we'll share ideas together. That way you don't have to add them all up. Calculator if you need to, obviously. Hopefully you don't need a calculator, add like 0 and 5 together, but. So Ashlyn and Sydney, what did you get for the next one here? 66. Yep. 44 and 22 is 66. Last one. 136. If we go to column 2.
100. 107.
180.
Third column.
47.
What's that?
180.
Last column.
5. 261. 19.
Yeah, and everything looks pretty good there. Addition's very easy. Identify corresponding parts, add them together. We can define some other matrices if they have specific values. For instance, let's pretend that matrix M had a 0 in every element, not only the top right corner, but every other one. The term that we give it is the 0 matrix, which makes sense. Again, 0 matrix is where every entry is 0. Additive inverse matrix. Suppose if I asked you, this is going back to last week, what would be the additive inverse of 4? Good review. Yeah, -4. So 4 and -4. What would be the additive inverse of -7? 7, and so on. Opposites. That's all it is. So we can use the same concept when we work with matrices as well. It's called the additive inverse matrix, and we'll get to that one here in a little bit. If you would like to put these definitions down, that's okay. In Algebra 2, we don't focus heavily on definitions. In fact, if it's an important one, I'll make sure to let you know to get it down in your notes.
So we need to write them.
I would not. No, I wouldn't take the time for it.
Mr. Vogt,
Yes.
what does it mean by a matrix that's 0?
A matrix in which every element, thank you, yeah. We did matrix addition. We're also going to do matrix subtraction today. Same concept, identify the same elements and subtract the two. Be careful with your negative signs. If we subtract these two, 3 minus a -1. 2 or 4? 4. Again, 3 minus -1, two-stroke method. On your own, go ahead and finish. I wouldn't necessarily worry about calculating that. I would. No. If I think if I feel it's an important definition, I'll have you write it down. I put it up on my screen just so that I talk about it, share it with you guys. Next element, Addie,
7.
bottom left-hand corner.
-5.
Bottom right. Should come up with -14. We've done addition, we've done subtraction. It's really nothing new. All we've done is do it numerous times. Okay, this is getting to the idea that I was talking about before, additive inverse. The additive inverse of 4 is -4. The additive inverse of -7 is +7. So if we want to find the additive inverse matrix of this one right here, we simply just switch the signs, am I right? -10. What's the opposite of 0? 0. Okay, there is no -0. 3. And what would we get if we added these two together? Let's use our terminology. 0 matrix. Very good. We'd get the 0 matrix where every element is 0. We can solve matrices just like when we had 4 plus x equals 7. All right, elementary students, how did we solve for x? Well, we subtracted 4 to both sides, right? It is the exact same concept today. using our matrices. We have the first matrix plus some matrix X is going to equal this one. So how do we solve for that matrix X? Well, we have to subtract this matrix to both sides. And just like back in the day when we would check our answer here, we would take 3 and plug it in. Yes, 4 plus 3 is 7. We could do the exact same thing here if we wanted to. We could take the 2, 2, -7, -7, plug it in there, and see if we come up with that matrix as well. That is solving matrices. Solving for particular variables within a matrix. Another good example. Notice the sign in between those two matrices is an equal sign. Let's start with this D. What do you suppose the value of D would be? Yeah, corresponding parts, it's going to match up. So D is going to be equal to 3. Let's start with A. Or go back to A. A plus 12 is equal to 18 over here, right? Well, it didn't set up exactly nice for us. It wasn't as straightforward. But we do know that that first entry is A plus 12. And that has to be equal to that value of 18. Therefore, by our algebra, A must be equal to 6. If we go to B, 2B is equal to -14. Divide both sides by 2, -7. And lastly, if we locate where C is at, here it is. Now this A plus C, that one needs to be set equal to 23. Two variables in a single equation, we don't know how to solve for that. But the good news is we already found the value of A, correct? So let's go ahead and plug it in. 6 plus C is equal to 23. Subtract 6 to both sides. There it is. Okay with that idea? We are just about done. Hang with me. Last thing we need to talk about is scalar multiplication. When they use the term scalar in the book, it's simply what you multiply by. So suppose you have a matrix A, and they want us to find 2A. Well, simply what we need to do is take 2 times whatever that matrix is. And then do it for every element. 2 times -1 will get us -2, 8, 6, 0. In the homework, you are going to have problems like this. And they're going to give you matrix A and B. What you have to do is you need to multiply those matrices first, then add the 2 together. Multiply first, then add. The other thing that I failed to mention at the beginning is when you add or subtract matrices, you have to make sure that the dimensions or the size are the same. Notice this was a 3x4 and this was a 3x4. If this was a 3x4 and this was a 4x3, you could not add the 2 together. Okay, so not every matrix is allowed to be added or subtracted to another one. Dimensions have to be the same. Let's go ahead and do A through E.